Hello, this is Bhaskar Jodin Datta. I will be giving a presentation on artificial intelligence planning in robotics. Now let's come to planning and robotics. Planning, as as it's known, is an important aspect of the effort to design robots that perform tasks with some degree of flexibility and responsiveness to the outer world. And one method that human beings use in planning is the hierarchical problem decomposition. A seemingly simple task, such as breaking a problem into dependent sub-problems, actually requires sophisticated heuristics and extensive knowledge about planning domain. A robot that blindly performs sequence of actions without responding to changes in its environment or being able to detect and correct errors in its own plan could hardly be considered intelligent. Now, the earlier models of intelligence, it's being first coined by Kenneth Craig in 1943. It shows the perceive, think, act model of intelligence. There is the perceive, think, act for the robotics by 1960s. We had the simple vision systems, the simple theorems of proofs, and simple path planning. And together, putting all of them, we came towards the Shaky project. The Shaky, this you can see the Shaky Robo. This is Shaky Robo. It was built in the at Stanford Research Institute. Shaky was remotely controlled by a large computer. It hosted a clever reasoning program fed very selective spatial data derived from weak edge-based processing of camera and large range measurements. It could formulate and execute over a period of hours plans involving moving from place to place and pushing robots to achieve a goal. This is an outline of Shaky. As you can see, the wall model can be outlined as the Planex, strips, ILS, LLS, and hardware. It gives out the central representations and logic-based and our error recovery at several levels and communication through the model. The key ingredients, as goes the geometric planning, the ILS who did a simple error recovery via the reactive controllers. The major recovery done by updating the wall model. The wall model based on the first order predict logic. This you can see the logical representations as can be seen by the commands type in, type add, and join faces and join rooms and so on, as you can see in this diagram. Thereby going to the coding, you can see the block door dy and the following syntaxes that follows these diagrams and the syntaxes as being given. There comes the planning, how the planning is done for the Shaky robots. The idea is to find an action that directly achieves your goal, and then actions to achieve the first action precondition. Shaky could learn to chunk useful sequences of actions into single large actions called macrops, but strips was slow and weak, and Sussman anomaly. For Shaky, it looked promising, but it worked in a restricted environment. The question is, was it extended to the natural world? So after 20 years, the approach still didn't extend it much. The visual modeling was too hard and slow, and NP was incomplete. Feedback through wall model was very cumbersome. People began to wonder if the ideas were right. Then it came the AI planning in mobile autonomous robots. As you can see here, the AI planning in a mobile autonomous robot soon after Shaky. As you can see the flow chart here. The strategic knowledge gave the goals. The strategic module selected the goal, thereby planning the module, and the planning module goes to the plan, then again plan executor goes to the strategic model. From the continuous wall state, etc., the quality of wall state was given to the planning model, and from there the actions were also being taken, and finally the current action was being taken from the plan executor. Thereafter, an AI planning paradigm to robotic assembly planning. SPARA was a task planner that was implemented on Puma 762. SPARA is capable of formulating many manipulation plans to meet specified assembly goals. These manipulation plans include grasping and regrasping operations if they are deemed necessary for successful completion of assembly. SPARA go beyond AI planners in a sense of SPARA is capable of solving geometric goals associated with high-level symbolic goals, and it was implemented as a non-linear constraint posting planner. Thereby came the fifth generation computer systems project. It was an initiative by Japan Ministry of International Trade and Industry, whose plan to perform much calculation and massively parallel computing processing. It was the result of massive government industry project in Japan during the late 1980s. It aimed to create an epoch-making computer like supercomputer performance and provide a platform for future development of artificial intelligence. Then came the Deep Blue. As you have known, it was a chess-playing computer which defeated Garry Kasparov, the world champion, with 2 wins to 1 of the 3 draws. It was developed by IBM in May 1997. Thereby, the DARPA Grand Challenge gave artificial intelligence planning a big leap. It was the prize competition for American driverless vehicles by Defense Advanced Robotics Projects Agency. The initial DARPA challenge was created to spur the development of technologies needed to create the first fully automated ground vehicle capable of completing autonomous ground vehicle, completing a substantial off-road course with a limited span of time. Thereby came the 2005 Grand Challenge. There were the vehicle called the Stanley Sandstrom Highlander K5 and Tira Max. These were from the various teams came from the Carnegie Mellon, Stanford, Louisiana, Wisconsin. They had done a lot of artificial intelligence planning for these robots. Stanley was the winner here. Then came the 2007 Grand Challenge. There were the Tata Racing, Stanford Racing, Victor Tango, MIT, the Ben Franklin, the Cornell. There, finally the latest came the 2012 Grand Challenge. Here the teams were the Cornell, the Insight, Team Case, the Kim Guy, Team Lux, Jeffron, Sting Racing, Victor Tango, Team Guster, Nation, MIT, and Austin Robot. The languages that is being mostly used were the C++, MATLAB, Java, C#, and operating system we're using like a Windows and Windows, Linux, Fedora, and hardware was mostly the microcontrollers with 17 dual-core servers, Mac Mini. Now then, AI planning of the latest that 2012 DARPA robots were the most like Cornell, which provide the planning involve basically the Bayesian mathematics. In 2008, the Cornell released the full source code under Apache license 2.04. So you can see that the Tartan Racing, which gave the artificial intelligence planning a big leap. It employed a hierarchical control system with a layered mission planning, motion planning, behavior generation, perception, and world modeling and mechatronics. So there ends my presentation of artificial intelligence in robotics. Thank you. Have a nice day.